Today we are going to be looking at how the drum on a roller packer works and how the components relate to each other. The example machine we are going to use is this Case W602 PD padfoot roller. When identifying packers, you will normally just identify it by the make and model. But if someone is not familiar with that particular make and model, they may ask for the size. How you tell size is normally with the width of the drum and as well as the weight of the packer possibly. Usually it's just drum width. This packer is a 72-inch. Another way to identify it is to say if it's a pad foot or a smooth drum. A pad foot has these pads welded to the drum, and a smooth drum would just be a smooth round drum. Another name for a pad foot is a sheep's foot. Due to after the roller rolls by, it looks like some really heavy sheep were poking holes into the ground. This style of roller packer has two frames held together by a hitch. The front frame holds the drum, and the rear frame holds the operator station, engine, pumps, etc. Vertical pins and hydraulic cylinders allow the machine to steer in an articulated fashion. Horizontal pins allow the machine to oscillate over uneven ground. The rear drive axle is rigidly mounted to the rear frame. The axle is driven hydrostatically by a motor. This motor is often a reversible 2-speed. The drum on the packer is also powered. Again, the motor is usually a reversible 2-speed. The drive motor for this packer is on the left-hand side of the machine. Many packers have one switch to control high, low drive speed. Others may have two switches that control the drum and axle independently. Doing this can increase the tractive effort to non-spinning drive members. For example, let's say when traveling in low speed on flat ground, both motors have equal load and doing equal work. Let's say it requires 2000 psi to maintain movement, and the flow from the pump is shared equally between the drum and the axle. Now the machine starts climbing a hill. Let's say both motors have to be at 4000 psi to overcome the extra load of climbing the hill. Now imagine at 3500 psi, the front drum loses traction and starts to spin. The maximum pressure the system can build to is 3500 psi, and then all the flow goes to that front drum. That's causing it to spin faster and making a bad problem worse, and you're officially stuck. Now, let's say the operator places the drum in high speed and leaves the drive axle in low speed. We made the drum motor smaller. That means it'll take more pressure to produce the force necessary to break traction. Now the pressure rises and becomes high enough that the lower torque output of the drum and higher torque output of the axle are great enough at, let's say that takes 5000 psi, the machine climbs the hill without spinning. If we looked at how much load that each motor carried, it may be 30% on the front and 70% on the rear in that situation. This is the drive motor on our drum. It appears to be a cam-type piston motor. It mounts directly to the front frame. It drives the drive plate, and that transfers rotary motion to the drum through anti-vibe blocks, also called isolators. Their purpose is to limit vibration from transferring to the machine. This is the right-hand side of the drum. Packers are very heavy for their size. They pack the ground just by rolling over it with their sheer weight. But if the drum vibrates, it can pack the ground up to about 30 feet below the surface, depending on soil condition. The hydraulically driven vibrator sits in this side of the drum. The left-hand side of the vibrator runs on the large roller bearing you see. The open hole you see is for filling with oil. The other hole is to have access to the hollow drum to add calcium or diesel fuel for extra weight if you desire. This is the vibrator for the machine. There are different styles of these, but the principle is the same. This is an eccentric style. The vibrator rides on roller bearings and is hydraulically driven. The vibrator's weight is offset from the bearing center line. So as it spins, it is out of balance. The vibrator is filled with heavy ball bearings, as well as an angle iron wall welded inside. When you spin the vibrator one direction, all the weights end up being at the very outside of the vibrator. If we spin the vibrator the other direction, that angle iron wall grabs about half of the ball bearings and holds them closer to the center line of the shaft. This makes the vibrator half as unbalanced. So if we spin it one direction, we get very heavy, high vibration, high amplitude. If we spin it the other direction, it's about half the vibration, so low amplitude. This machine uses a fixed displacement axial piston motor to run the vibe. Components needed to finish off the right hand side of the drum are the hub. It holds the other vibe bearing, the right hand side. Wheel bearings. The wheel bearings mount on the axle spindle. The axle spindle mounts to this plate. The plate has isolators bolted to it, which then bolt to the front frame through various styles of brackets. These brackets are adjustable to align the drum to the frame and provide preload for the isolators. Last but not least is the scraper bar. Both sheep's foot and smooth drum packers have scraper bars to remove material that sticks to the drum. They will scrape in both directions of machine travel and need to be adjusted regularly to provide proper operation. Pad foot packers supply very good ground compaction when soil conditions are soft. Smooth drums provide very good compaction and a nice surface finish, so they're used for things like finishing base material for roads, packing pavement, etc. Some companies don't want to have two packers on site, so they may purchase a smooth drum and then a clamshell kit to bolt onto that smooth drum to change it into a pad foot. Check out this 3-minute video from Bomag, just in case you ever have to perform this operation in the field.